702 and Cape Talk.
The Naked Scientist.
Good morning to you, Chris.
Morning.
I thought carbon dioxide and coal were both bad, but this is an interesting story about turning the one back into the other.
Yes, this is a very interesting study which scientists in Australia have announced, which is the discovery that it's possible to turn carbon dioxide, for instance, from burning fossil fuels, back into a coal-like material. What they've done is to take an electrolysis cell and they use a liquid catalyst. So this is molten gallium. Now, gallium actually melts at a really low temperature. You could make gallium melt in the palm of your hand. And they've added to it another element called cerium. And when you have a very tiny amount of cerium, it endows this gallium with very special properties so that when you mix it with a solvent containing a lot of carbon dioxide and you pass a small voltage, 0.3 volts, through this cell, the carbon dioxide molecules are ripped apart. The oxygen is given temporarily to the cerium. The carbon precipitates as this sticky, sludgy stuff like brown coal, and then the cerium regenerates itself from the oxide, and the whole system carries on. And because it's a liquid surface, there's nothing for the carbon to stick to, so it sticks to itself. And you get these flakes of carbon resembling coal after running this for a little while. It's just a proof of concept, but according to the researchers, this is Torben Danica and his colleagues at the RMIT in Australia, it could be scaled up so that you could have a system that would run on, say, renewable sources of electricity, solar power, wind power, tidal power, etc. You could use that electricity to drive this electrolysis cell and pull carbon dioxide out of the atmosphere. And you could therefore use this to offset some of the effects of us releasing on the order of 40 billion tonnes of CO2 into the atmosphere every year, which is what we're doing at the moment. And by turning it into coal, the critical thing is that because coal is a long-term stable form of carbon, which if we just collected carbon dioxide, that isn't, it's a safe way to store large amounts of carbon into the future for potentially millions of years. So you could use renewable electricity to drive the process because it's going to take a lot of energy to do it, but then put the carbon into a stable form that won't then be storing up trouble for tomorrow.
Interesting. Dennis, good morning to you. Welcome to the show.
Morning, Dr. Chris Smith. I want to ask you something that I've watched on GSTV when they want to bring down an old building and they want to build a new one. And this thing is made out of steel. Now, what they do is they take explosives and then they make a small little section and they put it on the steel, and then they do it to all the supports. The question is just absolutely mind-boggling that what is actually cutting through this steel column? It's absolutely amazing. Is it a sudden rush of air? Is it fire? What is it? They talk about meters per second, and then they sometimes talk about shaped charges that they put on. So in layman's term, what is actually cutting the steel?
Yeah, there's a range of ways of doing this, actually. One of them is that obviously you can use heat, and you use something like an oxyacetylene torch, because if you use a torch with high temperature, you effectively burn through the steel, raising the temperature to above its burning temperature in oxygen and air at the point where the torch cuts through the steel. So you just melt the steel away. That's one way of doing it. The other is to use an abrasive process. And in some of these cases, what they do is to fire sand or other fine particulates, or even gas can sometimes be used, because if you fire enough particles at something fast enough, they're going to hit it hard enough to knock bits off. And so these are all ways of doing this. So thermal or physical abrasion to literally cut through the steel. I don't know about the gadget that you specifically have seen, but those are the common ways of doing this.
Nhlanhla, good morning to you. Welcome to the show.
Thanks, Eusebius. Look, Dr. Chris, I just want to ask a question about the probability of winning a lotto, because I've been trying to play the same numbers for some time now, and I haven't actually got anything. So,
okay, let's talk probability reasoning, Chris.
Yeah, I think that the probability, we knew that by ringing the programme you hadn't won, because you wouldn't be listening to us, would you, if you'd won the lottery? Because you'd be off on your island that you'd bought somewhere and sipping cocktails, I would hazard a guess. The bottom line is that it doesn't really matter what numbers you choose in terms of your odds of winning, as long as everything's fair and equal, the machine is working in an unbiased way, because basically the way these systems work is that they're picking a set of random numbers. And if you pick the number 1, 2, 3, 4, 5, 6, you have an equal chance of that winning as if you pick a random smattering of numbers, because although you're picking a sequence of numbers, that sequence is no less likely than picking random numbers. Where strategy does come into this a bit is if you think about picking numbers that are very different from the ones that everyone else would choose, this could affect how much you win. Because if you get lots of people who have all chosen the same sequence of numbers, you may have to share your winnings with lots of people. If you've chosen really bizarre random numbers, your chances of winning are no different, but your chances of sharing your prize with other people are very different, and that means that you may therefore go home with more money in your pocket. Myself, obviously I'm a great believer in you've got to be in it to win it, but I tend to be quite sanguine about this, and the reality is that in most lotteries you have a higher chance of being hit by lightning than you do of winning the lottery. I haven't been hit by lightning yet in my life, so I reassure myself I've probably saved quite a lot of money not buying lotto tickets, and so I just spend the money on a decent bottle of wine every few weeks instead.
The other thing Nhlanhla said that I'd like you to explain, Chris, is he plays the same numbers over and over again. Is the gambler's fallacy just a result of poor literacy when it comes to our mathematical reasoning in the general population, or is there a psychological element to it?
You could argue that actually there's an evolutionary reason for doing this, because we have evolved to spot associations between things and also to seek out novelty. And so when something happens to us, we tend to look for things that are connected in space and time with that thing happening, and then we attach significance to it, because if the events are linked, that could be beneficial to us in the future. Equally, when we have a run of bad luck, we assume that that run of bad luck is because such and such has happened. And for that reason, we attach significance to a coincidence. And we all fall into this trap all the time. Oh, the number 7 hasn't come up for ages, so I'll choose number 7. In fact, someone told me a joke the other day, and they said they went to the races on the 7th of July, and they had £700, or, you could say 7,000 rand, whatever you want to say, in their pocket. And it was the last amount of money they had in the world. And they saw this race, and it said the 7th race, there was this horse called Lucky 7. So this guy goes, right, okay, 7th horse in the 7th race on the 7th of July, and I've got £700. I'm going to put all of it on Lucky 7. And of course it came 7th.
Tuli, good morning to you.
Good morning, Fabius. I just want to ask if the WOW signal, which was received on 15 August 1977 by the Big Bear Radio Telescope, if it's irrefutable evidence that we are not alone in the universe. If not, why not?
The WOW signal, okay, I've never heard of that. Maybe Chris has?
No, I mean, people have been detecting things from space for a long time, and because they're detecting lots of signals from lots of places in lots of different ways, occasionally you will see apparent patterns. There were also things detected called pulsars, and Jocelyn Bell Burnell was the PhD student in Professor Newish's lab when they spotted this, and they saw these repeated bursts of radio information coming from this distant star. And everyone assumed, wow, this is little green men, this is the signal for aliens, but actually it turned out that that's the natural behaviour of this particular species of stellar body. So we have looked for a long time. We have occasionally seen signals that appear to have some kind of pattern, but we haven't seen anything yet that says little green men. People have detected in recent years, we've seen other examples of these bursts and repeating bursts of radio and other types of waves, but we don't know exactly what's causing them, but we also don't think that they have intelligence behind them at this stage. We haven't found anything that would convince us that there's someone out there who thinks like we do. That doesn't mean they're not out there, it just means we haven't detected them yet. But the way to think about this is, if you consider we've been emitting radio signals from the Earth for 100 and something years. That means that given that radio signals travel at the speed of light, so they're doing about 300,000 kilometres a second, there is now a bubble of radio information travelling away from our planet, which is just over 100 light years in radius. And that's not very far in terms of how big the universe is. And as a result, if other civilizations and other intelligences are out there and they're behaving in a similar way, their bubble of information may be travelling the same way ours is, but maybe still very close to them, and we just haven't had a chance to encounter it yet because we haven't been around for very long, and that may be why they haven't found us and we haven't found them yet. But we haven't found any convincing, compelling signals that would convince us there's life out there yet.
17 minutes after 10.
7:02 and Cape Talk.
The Naked Scientist.
Father Ted, what is your question?
Eusebius Chris, good morning.
Good morning.
I have an 8-month-old baby.
Congratulations.
Now, the doctors... Another funny congratulations, but thank you nonetheless. and I never did all the work, the wife did. But anyway, they say breast is the best. You know, so the baby will drink the same breast milk from birth up until 1.5, 2, 3 years, whenever the baby stops drinking milk. Now, why is it when you buy formula, because I was on formula, when you buy formula, it says 0 to 6 months, that's number 1. Then 6 to 12 months, number 2, and so on and so forth. So what I want to find out is, why is it they haven't been able to develop a milk or formula that is as good as breast milk that the baby can drink the same formula from birth up until? Or is there something in the breast milk that the baby is being given that the baby doesn't necessarily need?
Okay.
That would be suggested by the fact that formulas change from 6 to 12 to 18 and so forth months.
Okay, put more pithily, Chris, what's so special about breast milk?
It's absolutely right. Breast is best, and there's a number of reasons for this. Firstly, the composition of breast milk does change a bit over the course of the baby growing. When the baby is first born, the first taste of breast milk it gets is something called colostrum. And colostrum is very poor in calories, but very rich in antibodies and other trace elements which are secreted specially by the mother. And they have a very profound effect, not on the circulating immune system of the baby, but by putting those antibodies into the intestine. It has a very strong selective effect on the microorganisms that begin to take root and grow and develop in the baby's gut and turn into that baby's microbiome, the spectrum of microorganisms that are unique and specific to that individual. So that dose of colostrum is very important for helping to set up the future microbial health of the intestine. The other thing about breast milk is it contains the right number of calories, which helps the baby to grow at a sensible rate. When we make these formula feeds, we're making an approximation to what we think the baby needs. And that's why you have to change this with the baby growing, because growing babies need enormous amounts of energy. They can burn off 30 or 40% of the calories they take in a day just trying to grow. And as babies grow bigger, they grow faster. So they need more energy, and they need more energy more often. The other thing that breast milk is good at is it's pre-warmed, and it's, unless you've got some disease that can be transmitted by breastfeeding, which you should know if you have that, then actually it's sterile, which means it's perfect. You don't have to worry about sterilizing things. You don't have to worry about clean water. Breast milk is perfect, pre-warmed, preheated, and sterile, with all of the nutrients in the right way. Now, when you make a formula, for convenience, you're taking something that's been freeze-dried. It's a dehydrated powder. You're adding water to it, and then hoping you get the composition correct and hoping you make it appetizing for the baby. So it is better to breastfeed if you can. There is a subtle compositional change in breastfeeding, and the volume of breast milk that the breast will make will also change as the baby grows, because the more demand you put on the breast to produce milk, the more milk it's going to make, which means you gauge how much you make to how much the baby needs. Whereas with the formula, of course, you've got to keep making a richer and richer supply of the formula recipe to meet the demands of the baby. So you have to think about that when you're using formula. You don't have to think about it so much when you're breastfeeding. But most babies, once they get to 6 months old, they're pretty hungry. And so they'll want both milk, plus you begin to introduce other things that will give them some extra calories as well. And who says 6 months is absolutely the right time? You should keep on breastfeeding for as long as you're comfortable with and the baby wants to, but also don't be frightened to introduce little bits of food from a few months of age, because actually babies do get hungry, and very often the reason they cry at night is because they're starving hungry and they want more food. So if you can begin to get extra calories into them sensible foods, not hugely strongly flavoured, high salt things. You've got to be careful what you expose them to, but little bits, little and often, and see what they like, and then just increase it from there.
Thanks for that question, Ted. Amanda, good morning.
Good morning. I'd like to know, why does the end little stub of a bar of soap, why doesn't it lather the way a full soap bar does? Is it purely a surface area thing, or does the center of a bar of soap actually saponify differently to the outside?
Yeah, this is a very interesting point here, because when you get down to the last knockings of your soap bar and you rub it on your skin, it doesn't seem to make the same lathering as it did when it was new. There's a number of aspects to this. One, as you completely correctly identify, is the surface area. If you think about it, the amount of surface of soap that's in contact with your skin when you have a big bar of soap is far greater than the amount of soap that's in contact with your skin once the bar is shrunk down to a finger-sized nub of soap that's left behind. So part of it is surface area. The other thing is that there are other ingredients in the soap beyond just the soap which give it its characteristics. There are various things that make the soap have a smooth and a nice feel. There's also the smells and other chemicals and other foaming agents. And they're going to be in shorter supply because often those molecules are smaller and easier to release from the soap than the bigger soapy molecules. And as a result, you tend to find that the stuff you've got down deeper into the soap bar, most of those have been lost by the time you get to there. So what you're left with is a much harder soap with fewer of those other attractive, nice smelling compounds, perfumes, and the other foaming agents. So it's a combination of factors. Surface area probably most important, followed by the loss of the other ingredients that give the soap its characteristic that we've become familiar with when the bar was bigger.
Solomon, good morning to you.
Good morning. How are we?
We are well. What's your question? Go ahead, Solomon. What's your science question?
I'm wondering, is there any relation between the amount of rainfall that we get in rocky areas than where we don't have any rocks or mountains at all?
Hello, Solomon.
Okay, so whether there's a link between rainfall patterns and rock formation. Chris?
Yes, there certainly is, which is that where does rainfall come from? Well, it comes from the sea. Because when you have sunlight illuminating the sea, energy from the sun falls on each square metre of Earth on average at the rate of 1 kilowatt. So you're putting a kilowatt, energy at the rate of a kilowatt, into each square metre of ocean, which evaporates water. That water vapour rises into the air. Because the air is warm, the air is rising, because it's less dense. As it rises, it expands, and because it expands, it cools. Because it cools, it can't carry as much water vapour, so the water condenses and you get water droplets, and that we call a cloud. Now, as that air mass moves towards land, if it starts to see high rocky areas, then actually you end up with thermals rising off of that, pushing the air upwards. But this can displace your clouds upwards, where they can't go because they're heavy and they're full of these droplets of water. So as a result, you encourage more water to precipitate there, and it rains. And you end up with an increase in rainfall on one side of high ground and then a rain shadow on the opposite side of the high ground. So it's absolutely true. If you've got a flat area, if that's downwind of a rocky area, it's going to see less rain than the equivalently possibly flat area upwind of the rocky area, because that area is seeing the air masses having to rise, and it drops its rain on that side of the mountains.
702 and Cape Talk.
The Naked Scientist.
Okay, we've got a couple more minutes with Chris. Meenakshi, good morning.
Hi, good morning, Chris and UV. My question is, why, life started as this inorganic, self-replicating molecule. But I don't understand why life feels the need to replicate. If the molecule replicated once or twice, yes, it's fine. But why does DNA feel such a powerful need to replicate itself? It's almost like, the universe doesn't care whether you replicate or not.
Yes.
So why does life feel the need to replicate?
Hello, Meenakshi. What an interesting question. A good bit of philosophy to shove in at the end there.
Can I tag, speak of philosophy, Chris, can I tag a second part to that question as the philosophy student in the Peanut Gallery here? When you guys talk about science in popular terms, why do we do typically what Meenakshi does? Is it just because that's a good way to explain things? In other words, to anthropomorphize DNA, because presumably it doesn't take decisions.
Yeah, it's a common trait among people seeking to explain complicated things. And I think the reason is that people are more comfortable embracing the unfamiliar through the lens of the familiar. So if you start with something with which people are familiar, then you can say this is a bit like. So when we're talking about, say, a bacterial cell, it's very hard to imagine something which is a millionth of a metre in diameter and a cell which might have some long stringy bits sticking off it. Whereas if you say these are like the bricks that your house is built from, and people imagine that sort of shape. And then they think, oh, right, okay, if you imagine shrinking that down to, a fraction of the width of a human hair. So I think that's part of the reason. But going back to the initial point, which is, why does life feel the need to replicate? I think the point is that when you have a system that can organise information and organise raw materials into an organised way, then if you have a huge amount of raw materials, then that can be used to make something that then makes a lot of itself. And it's an inevitability that it's going to then grow and expand and inflate its numbers. Also, you need things that are capable of growing and inflating, replicating, growing their numbers, because the whole universe is trying to move towards disorder. This is called entropy. Things are trying to break apart, be less organised and more disrupted. And if you don't have a system that is capable of reversing that effect and making more of itself, then the inevitable things that are going on in the universe with entropy and spreading everything out and disorganising everything would mean that even though you had made one of yourself and that was very nice for you, you'd eventually move towards disorder and you'd be disturbed and disrupted. So the universe is trying to take you apart all the time. You're trying to put yourself back together, and in the process you make a spare one of yourself called your children, and that gives you a second chance at this. And that's what's going on. I mean, I can't think of another way to explain it. I'm going to take the question away and have a think during the week, though, of another way to explain this, because I think it's a beautiful question, probably one of the best ones we've had in a long time.
Stunning question. Thank you so much for it. Solomon, another Solomon, what is your question very quickly?
Hi, CBS, Chris. I've got a 7-year-old daughter who's been diagnosed with Tye-George syndrome. It's a deletion of the microchromosome 2211 in the blood. I just wanted to know if it was possible. I've saved my second youngest daughter, who's now 4 years old, stem cells, if anything can be done to correct the situation.
Hello, Solomon. Well, first of all, I'm sorry to hear about this. For people who are not in the know, Tye-George syndrome, as Solomon has highlighted, is a genetic problem, and it leads to a range of problems that the people who are affected have. This includes problems with the immune system and other bits of the body. There is a possibility that you can reverse some of this with transplants, yes. And you need a compatible donor, and therefore family members are the go-to people because they will have the best compatibility with the individual who has the problem. So it is definitely worth pursuing that. And if you do have the stem cells, I presume you mean umbilical cord blood stem cells that you're referring to, which are collected at the moment when a baby's born. If you have those and you have that daughter is completely healthy, if they're a good genetic match, then there is a possibility that the immune system problems can be reversed with those stem cells. But you certainly shouldn't listen to me. You should certainly seek the advice of an immunologist who can look at the situation objectively for you.
Thanks for all your questions. Chris, we'll do it again next week. Thanks so much.
I'm looking forward to it. Thanks, everybody. Have a great weekend. See you next time.